Welcome all my dear students to Sudharma's physics classroom. We are on the chapter electricity from CBSE grade 10. Today's discussion is about heating effect of electric current. In the previous videos, we have discussed up to electric power, commercial unit of energy, and calculation of energy consumption in household, and how do we calculate the cost of electricity. I'll be providing the link for those videos in the description box. So let's start with today's topic, that is heating effect of electric current. We know that when electric current passes through a conductor, there will be heat generated in that conductor. So let's say, for example, we don't have to worry about what a conductor is and how do we get a conductor to experience that heat energy. You can try at home whichever electrical devices you are using. If it is used for some time, for example, the laptop, nowadays you are using laptop or mobile phones for the online classes, right? So if you use it for long hours, you can feel that it is becoming hot, right? So what makes it hot? So that gives the, and there we get the answer. It is the heating effect of electric current is providing that heat energy to those materials. Okay, so we can explain the heating effect of electric current or the amount of heat produced in a conductor using Joules law of heating. This is very, very important. We have to learn Joules law of heating, and you may get a question like, what is explain Joules law of heating or state Joules law of heating or express it mathematically. These are the questions we can expect from this part. Okay, so according to Joules law of heating, heat produced in a conductor is directly proportional to square of the current. Heat produced is directly proportional to the resistance of the conductor, and heat produced is directly proportional to the time through which this electric current is passing through the conductor. We can combine these three proportionalities. H is equal to I square R T. So this is our Joules law of heating. Now you will be wondering, we have seen this equation before, right? We have seen P equals I square R and E equals I square RT. So this is the same thing. Energy is equal to power into time. Power is equal to I square R, that multiplied by time will give you the heat produced, with the energy dissipated in the form of heat energy. That is why we can write as H. It is nothing but energy, and the unit of heat produced is Joule. Because see, now you can relate with Joules law and the unit of energy, Joule, right? Okay, so H equals I squared RT is the Joules law of heating mathematical form. So in a conductor, if current is more, then the heat produced will be more. If the resistance is more, then also the heat produced will be more. If time is increased, if say instead of 1 hour, if you allow the current to pass through for 2 hours, then the heat produced will be more, provided current and resistance same. Even if the time changes, accordingly the heat dissipated will be changing. Now let me ask you a question. We say that the electrical devices get heated up, but why the connection wires are not getting heated up? Hope you understood the question. When we touch the connection wires, for example, the adapter, the wire coming from the plug to our laptop, when you touch it, even after long hours of usage, you won't feel much heat produced in that wires. But when you touch your laptop, a small amount of heat you can feel. What would be the reason behind that? The reason is the connection wires are made of copper, right? So copper is a good conductor of electricity. Copper has very low resistance, right? When resistance is very low, according to Joules law of heating, heat produced is directly proportional to resistance. So when we have a conductor of very low resistance, then heat produced will be low. Automatically it will be low. Hope you understood that. Now let's see some examples or real life applications of heating effect of electric current. We have the tungsten filament bulb. Filament bulb. The filament of the bulb is made of tungsten. So how this goes to the lighting effect of electric current, right? Why I am explaining that under heating effect of electric current? Because this tungsten gets heated up to a very high temperature and it start emitting white light. Okay, so tungsten is used as the filament of electric bulb because tungsten, you can see, if you have ever seen this kind of a bulb, you can see the filament, it used to be very, very thin. Okay, so tungsten, we can easily make it into small wires, thin wires. So that is one property of tungsten. That's advantage of tungsten. We are using that for filament of the bulb. One of the properties. Okay, there are many. Okay, so we can make it into thin wires and it get heated up. The moment you switch on the bulb, this tungsten filament get heated up to a very, very high temperature. So that may go beyond 2500 degrees Celsius. Imagine that, right? If you have seen this, even if you sit under this bulb, you will feel that heat, because the heat will be radiated from this bulb. Through air it will be reaching us. So it's really difficult to sit under this bulb, because it wastes a lot of energy in the form of heat. But it emits white light by heating up to a very, very high temperature of around 2500 degrees Celsius. Okay, but what makes it this tungsten important to make the filament of electric bulb? This it's working based on heating effect of electric current, right? So when it works on heating effect of electric current, the tungsten filament gets heated up. Any material, when it gets heated up beyond a particular temperature, it starts burning, right? If it reaches the ignition temperature, it starts burning, or sometimes if it reaches the melting point, it will melt. Okay, but this tungsten has a very high melting point, very high melting point. It has a very high melting point. Okay, so this is one of the important property, around 3380 degrees Celsius. Okay, approximately this value. Okay, so this is the major attraction why we are choosing tungsten as the filament of electric bulbs, because the filament should not melt even if it gets heated up to high temperature, right? And it is very flexible, highly flexible. Okay, and low rate of evaporation. What do you mean by that? See, some metals, when it goes beyond a temperature, it starts vaporizing, or it starts reacting with oxygen. So it has a very low rate of evaporation. Okay, so another thing is, compared to the other metals, and we are making it very, very small, very thin filament, right? We know the area of cross section is decreasing, right? When area of cross section decreases, the resistance will be increasing, right? Resistance is inversely proportional to area. So thickness of the wire increasing, then the resistance will increase. So we can make, while making it into thin filaments, very thin filaments, we are increasing the resistance of that material. Okay, so when resistance increases, according to Joules heating, we know that heat will be more when resistance increases. So here, to make tungsten get heated up really fast, we need a material having a high resistance. So we take tungsten as the filament of the electric bulb. Now, there is a possibility for this tungsten at very high temperature to react with oxygen. So what happens if any material reacts with oxygen at very high temperature? Definitely a fire breakout will be there, right? So in order to avoid that, there will be some inert gases filled within this glass tube. Okay, so normally the unreactive gases like argon, okay, argon or nitrogen. These are the common gases filled in this filament bulbs. So why we have to fill the glass tube of this tungsten filament bulb with inert gases? Because if it is not filled, then there is a chance for this tungsten to get oxidized, and it reacts with oxygen and it may catch fire at that very high temperature. Hope you understood about the filament bulb. So the keywords, because when we write in the exam, keywords are important as far as our CBSE syllabus is concerned, right? So the keywords are, definitely you have to mention Joules heating, because it works on heating effect of electric current. According to Joules law of heating, when the resistance is more, then the heat produced will be more, and accordingly the filament get heated up and it start emitting white light. Okay, so that is the main keyword here. And what are the specialities of tungsten to become the filament of an electric bulb? It has a very high melting point of around 3380 degrees Celsius. It will not melt easily, even if it goes beyond a very high temperature. Once it start emitting white light, this tungsten filament will not melt. It is very flexible. We can make it into very thin filaments, and it has low rate of evaporation. In order to avoid catching fire, we will be filling this glass tube with inert gases. Okay. Now let's see another example for heating effect of electric current. The application in real life. Electric iron. Electric iron, most of us know how electric iron looks like, but we don't know how it looks inside, right? So you can see here there is a coil. We call it as heating coil. Every heating device will be having a heating coil, and this heating coil will be made of alloys. This is another question. Why the heating coil of electrical heating devices are made of alloys? So when we were discussing about specific resistance or resistivity, you might have noticed a table there in our textbook. That textbook gives us an idea of all the resistivity of different types of materials. In that table, we have the classification like metal, alloys, and insulators, right? So metal comes under the least resistivity category, and alloys will have slightly higher resistivity compared to the pure metals. So when resistance is more, according to Joules' law of heating, heat is directly proportional to the resistance. So more the resistance, high heat will be produced, because without much loss of energy, we will have to produce a high amount of heat in this device, because this is very specific related to producing heat. In the case of tungsten bulb, filament bulb, we have to produce heat, then to produce electrical light energy. Electrical to heat, then to light energy. Here directly heat is utilized, right? So do you know what material is used to make the coil, heating coil of this device? As I said, it is made of alloys, and especially it is made of nichrome. Even resistance, standard resistors are also made of nichrome. Okay, so that's about electric iron. So again, the key word is Joules heating. The resistance is more because it is heating coil is made of alloys. You will get mark only if you write all these points. Very valid points you have to write. Okay. Now coming to the electric fuse. So what is electric fuse? Electric fuse is a protecting device. So if excess current flows through the circuit, the fuse wire will melt. The fuse will melt and protect the circuit. Okay, so how it is going to protect the circuit? So if for any current to flow in a circuit, we need a closed circuit, right? So let me tell you an example. I have a bulb. So I'm connecting that to a fuse, then to the high potential. Okay, switch is required. I'm just showing only the fuse. This is the fuse. Okay, this is a fuse and this is the bulb. So if excess current flows in a circuit, this fuse will be breaking the circuit. So when breaking the circuit means this will melt and only these two portions will be, there is no connection between those two terminals. So the bulb is in a open circuit, then the bulb will not get affected because of that high amount of current. So every electrical device in our house is protected by the fuse of specified current rating. Okay, so this fuse wire is made of an alloy. Again, it is made of an alloy of tin and lead. Okay, it's made of an alloy of tin and lead. Heating coil of this electric iron is made of nichrome. Here it is made of an alloy of tin and lead. Why we have to use this alloy of tin and lead? You can see the fuse wire it's very thin, right? It's very thin. So this fuse wire has to get heated up really fast, right? If excess current is flowing, then the heat should be more. Then only it starts melting. So the characteristic of a fuse wire are it will be having low melting point. Okay, it has low melting point, and See, the area is very small, right? When area is very small, what happens? Resistance is inversely proportional to area of cross section. When the wire is thin, then the resistance will be more. High resistance. Okay? High resistance. To make it more resistance, then that is why we are making that into a very thin wire. Okay? So this material, you can see this is a cartridge type, right? A capsule kind of fuse. Different types of fuse wires are available, and different fuse wires of different current ratings are also available in the market. So we need to know how to calculate the current rating of the fuse wire. That we'll be discussing in the household circuit concept. Okay, I heard that is eliminated. That household circuit is eliminated from the syllabus for this year because of the pandemic. Okay, anyway, I'll try to make a video on that, because knowing that concept is important, right? No matter it comes for exam or not, we have to learn it. So high resistance, low melting point are the important properties of the fuse wire. Again, don't forget to write it works on Joules law of heating, because once it gets heated up, it has a low melting point, so the fuse wire will melt and the circuit will be safe because of that. Okay, so that's about the common examples in our real life related with Joules law of heating. Now let's try to solve some questions related with Joules law of heating. Okay, a potential difference of 250 volt is applied across the resistance of 500 ohms of an electric iron. Calculate the current and heat energy produced in joules in 10 seconds. So we have already seen these kind of questions, right? So let's start solving it. Okay, a potential difference of 250 volt, V is equal to 250 volt, and resistance R is equal to 500 ohms. So what is to be calculated? Current. What is the formula for current? I is equal to V divided by R. So V is 250 and R is 500. So this is 1 by 2 or 0.5 amperes. Very easy. Second part. We have to calculate the heat energy produced in joules in 10 seconds. So T is equal to 10 seconds. So what is the formula for heat energy? H equals I square RT. I is calculated 0.5 square multiplied by resistance is 500 multiplied by 10. Right? 0.5 square into 500 into 10. So we'll get 1250 joules. Okay, so make sure everything is in SI unit. Do the calculations properly. You have to pause the video and do the calculation. Don't copy this answer directly into your notebook. Okay. Another one. NCERT question. Calculate the heat produced when 96,000 coulombs of charge is transferred in 1 hour through a potential difference of 50 volt. Calculate the heat produced when 96,000 coulomb. So they have given charge. This charge concept we have discussed in the initial videos. 96,000 coulombs of charge is transferred in 1 hour. So time is 1 hour. We have to convert it into seconds. 1 hour is 3600 seconds. Right? And voltage is given. V is equal to 50 volt. Now what is to be calculated? Calculate the heat produced. So we have to calculate the heat. H is equal to I square RT. Right? This is our formula. So is current given here? No. Resistance is also not given. Right? Current we can find out. I is equal to Q by T. Right? I equals Q by T. And voltage is given. So instead of using this formula, I am going to use energy is equal to power multiplied by time, that is VIT. Right? So V is given. I am going with this formula because we have voltage given, current we can calculate using this. Right? We can do the calculation directly here. Okay? So if you want to do that, if you want to do directly with I squared RT, you can go ahead with the current, calculated amount of current, and then you can do the formula I squared RT. I'm just showing you the simple step. Okay, so current is not given, right? Current is not given, so but we have Q by T. V is given, so V into Q by T into T, right? V into Q by T into T. So let me write H is equal to Q. V is equal to 50 and Q is 96,000 divided by time is 3,600, right? 3,600 into time. What is time here? Again 3,600. Okay, so what we have done is, instead of using the formula H equals I squared RT, I have taken H is equal to, or energy is equal to, power into time according to the values given in the question. This makes the calculation simple. That is why I have taken this formula. Okay, so 3,600 and 3,600 cancels. Now what we have? 50 into 96,000, right? Now the calculation is very simple, right? So we get the answer 4.8 into 10 power 6 joules. 4.8 into 10 power 6 joules. Another way of solving is, you find out current from the formula Q by T. Because if you have to go with H equals I squared RT, you can take this as a homework. So find out current by using the formula Q by T. Then find out current, find out resistance using the formula V divided by I. Then substitute. Right? That means you will have to do 2-3 times this long calculations. So this gives you the answer very easily, right? That is why I've gone with this. You can take this formula H equals I squared RT calculation as a homework, and you can cross verify you are getting the same answer or not. Okay, so first you find out current using the formula Q by T, then you find out resistance using the formula V by I, then substitute in this I squared RT. Okay, so both the cases you will be getting the same answer, no doubt. Okay, now coming to the the next NCERT question. See, when I highlight this as NCERT, this is NCERT question, our textbook question. I will be giving you extra questions also. Why I have to highlight it as NCERT? If you study NCERT questions, more than 75% marks you will be scoring automatically. Okay, pure NCERT, if you have seen the previous last 2 years board exam questions, NCERT text back exercise and this exemplar questions, nothing beyond that. Okay, so learn that very thoroughly. You will score the maximum marks possible for you. Okay, there is no need to go with lot of other things and all. Okay, so we just need to practice whatever is given in our textbook. So let's do the next NCERT question related with this. Two conducting wires of the same material and of equal length and equal diameter are first connected in series and then in parallel in a circuit across the same potential difference. Find out the ratio of heat produced in series and parallel combinations. Two conducting wires of the same material and of equal length and equal diameters are first connected in series and then connected in parallel. So we have to find out they are connected across the same potential difference. So we have to read in between the lines now. Same material, equal length, equal diameter. That means the resistance. We have two wires. R1 is equal to R2 is equal to R. This is the first thing I can find out from the statement. They are of same material, same length and same diameter. They are connected in series and then in parallel. So if we are connecting two equal resistors in series, we have R series is equal to R1 plus R2, that is R plus R, that is equal to 2R. Okay. Now, if you connect them in parallel, Rp is equal to, we have two resistors connected in parallel, right? Equal resistors. R1, R2 by R1 plus R2. So, we have R into R divided by R plus R. That is R square by 2R. You will get R divided by 2. So, these are the equivalent resistances when they are connected in series and parallel respectively. Now, we have to find out the heat produced in series and parallel combination. So let's find out. They have the same potential difference. So I can go with the formula H is equal to V square by R into T, right? P into T, power into time. I'm going with this formula because they have the same potential difference. If I'm going with the formula I square RT, I will have to check what happens to the current when resistance is 2R, when what will be the current when the resistance is R by 2. Again, we don't have to go with the longer steps. We can use this formula because this formula is also correct. So heat produced in parallel is equal to V square by R parallel into T. Heat produced in series will be equal to V square divided by R series into T. Now, heat produced in series is equal to V square divided by R series. Yes, R series as per equation number 1, R series is 2R. Heat produced in parallel is equal to V square divided by R parallel. Time we have to multiply with time, I just missed it. So V square divided by R parallel. What is R parallel? R by 2 into T. This is equal to 2V square by R into T, because V square by R by 2, right? It comes in the denominator. So 2 goes to the numerator. So 2V square by R into T. Now what is the question? Let's go back to that once again. Find out the ratio of heat produced in series and parallel combinations. So that means H series by HP. So H series is V square divided by 2R into T whole divided by 2V square by R into T. So T and T cancels, right? So this is going to be V square by 2R into this R goes to the numerator, R divided by 2V square, right? So R cancels, V square and V square cancels, and we get the ratio 1 by 4. So heat produced in series is to heat produced in parallel, that is equal to 1:4. This is our answer. So no need to worry about the resistance is not given, nothing is given in the as a value, but we are getting a correct value here, right? We are getting the ratio in the form of 1:4. So finding out, it is in a series and parallel. If it is parallel to series, then it will be 4:1, right? So make sure you are doing the correct calculation, undergo just the correct steps you have to follow, you will get into the correct answer. This is one of the questions we can expect in our exam for 2 marks. Okay, so this is again NCERT question. So the chapter is almost completed. We have done all the NCERT in text questions during the classes. In text question, I mean when with each and every portion we have the some questions given in the boxes, right, along with the concepts. Those questions are already done. And during the discussion, the text back exercises, most of them are covered. So in the coming class, I will be explaining the NCERT exemplar questions. For those who doesn't know what is this NCERT exemplar questions, you can take the latest board exam question, 2020 board exam question paper. There are 3 sets of question papers. You don't believe all the questions were from this NCERT exemplar questions. These are the questions provided by the CBSE board, but they are little bit higher level questions. Okay, MCQs, if you check the MCQs, everything, not even a single value was changed in that question. So those who practice all these questions, they could score a very good mark with much confidence, because they have practiced it many times and they know the values, they have seen that many times. Okay, so it's very important, not only for physics, it's important to practice NCERT exemplar questions for all the subjects. Okay, so coming class, it has lot of MCQs and lot of application level, high level questions. So don't miss that video, because you will not get that solved in other classes. Okay, NCERT, because in school it is difficult to solve all these questions. So stay tuned for the next video. I will be coming with NCERT exemplar questions, which is it's a mark deciding factor in your board exam. Trust me, it is a mark deciding factor in the board exams. Okay, so see you with NCERT exemplar questions. So before that, you have to read the complete chapter and come practice all the equations and come back and see that next video. So thank you for watching. If you have not subscribed to the channel, please subscribe to the channel and click the bell icon for the updates on the coming videos. Thank you and see you in the next class with NCERT Exemplar questions. Bye.